Hey guys, welcome to my channel, and today we are going to discuss about finding a solution to this particular problem on your screen. So what is this problem about? You must have guessed it very right. This is a problem from the domain of complex numbers, and what you're supposed to do here is to find the smallest positive integer value for n, so that this expression 1 minus I by 1 plus I the whole raised to n squared is equal to 1 stands true. Right? Now, this problem actually appeared in the Union Public Service Commission exam. It's an Indian exam. It's considered to be one of the hardest exams in the world. The exam pattern generally has 3 levels: the prelims, mains, and then an interview session. So this appeared in the mathematics paper. Generally, the exam has various subjects, not only math. So it has English, it has math, and many other subjects. Now this, as I previously told you, is based on the basics of complex numbers. So let's get a pen and paper and start solving this problem. So what are we required to do here? It's quite simple. So we have 1 minus I by 1 plus I the whole raised to n squared is equal to 1. So we have to find the value of n for which this expression holds true. Remember that there could be multiple solutions. That's why the question clearly says to find the smallest positive integer, right? So let's try to simplify this expression as far as possible. So let's try to put this as 1 minus I by 1 plus I the whole raised to n into n, which is equal to 1. Now if you remember, this is quite simple. Sometimes people get confused with respect to exponents, so I'm just reminding you, n squared, let's assume if n is 5, then this would be 5 squared, and 5 squared is nothing but 5 into 5. So I have done the same thing, right? It's n squared, so I have just written it as a denominator with 1 minus I. So multiply the numerator and the denominator with 1 minus I. So what happens when we multiply the numerator and denominator with 1 minus I? We'll have a look. So 1 minus I into 1 minus I divided by 1 plus I into 1 minus I the whole raised to n into n, which is equal to 1. So let's take our problem onto this side. Now let's start solving from here. So we have 1 minus 2i plus I squared divided by 1 square, this is also square, sorry for that, 1 square minus I square the whole raised to n square. Now let's try simplifying this. So I square, so this 1 square is 1 minus 2i. Now I square is actually minus 1. So if you remember, I is nothing but root of minus 1. So from that logic, I square naturally is minus 1. So here you get minus 1 divided by 1 plus 1 the whole raised to n squared. Now as you can see over here, minus 1 and 1 would cancel out. So we are now left with minus 2i divided by 2 whole power n squared. Now remember, all of this was equal to 1. That is what we were discussing. Now we can obviously cancel out 2. So what we are left with is minus I n into n raised to n into n is equal to 1. Now let's get rid of this. And let's continue solving here. Now let's assume if n is equal to 1. Now if n is equal to 1, we would get minus I raised to 1 into 1, which is equal to minus I. But this is not equal to 1. Hence, we can say that n is not equal to 1. Now, if n is equal to 2, now in this case, we have minus I the whole raised to 2 into 2, which works out to be minus I raised to 4, which technically speaking is minus root of minus 1 the whole power 4. Now this expression can be written as minus 1 into root of minus 1 the whole power 4, which could be minus 1 the whole power 4 into root of minus 1 the whole power 4, which is 1 into minus 1 square, naturally because this is just the second root, which works out to be 1 into 1, which is equal to 1, which obviously was equal to our right hand side. In this case, n equal to 2 is correct. So we have found the solution to this problem. We can clearly say that for this expression, which is 1 minus I divided by 1 plus I raised to n square is equal to 1, we can clearly say that the smallest positive value of n is 2. So I hope you guys like this video. Please click on the like button, share it with your friends, and if you have any suggestions, probably you must have a much more easier method to solve this problem, please write that down in the comments. Or if you want me to work on some other problems, share those with me. Thank you so much.